Integration by substitution, I will just call it a u-substitution. So take a look at the first integral. We have integral 12x to the third divided by 3x to the fourth minus 2. We raise the whole thing to the fifth power. So clearly, you cannot just integrate the function term by term. So how u-substitution works though, the first step is you have to let u be a function. So in this integral, I will just let u equals to 3x to the fourth minus 2. So this we have to recall the composition function. So just look at the denominator. Do we agree that we have a fourth power inside a fifth power? So this is the inner piece, right? So this is inside a fifth power function. So therefore, I will just let u equals to this piece. If you take a look at the next integrand quickly, I will just let u equals to 2x to the fourth minus 10x, because this square root and the 2x to the fourth, this is a composition function, right? We have a fourth power function inside a square root function. Therefore, I have to let u equals to 2x to the fourth minus 10x. The next step is you have to differentiate u with respect to x, so which is du over dx, right? So that is equals to 12x to the third. The derivative of 2 is equals to 0, but I want you to do me a favor. You don't put the dx on the left hand side, just move the dx to the right hand side. So instead of having du and over dx, I will multiply dx on both sides. So therefore, we are not putting the dx down the du. So we are putting the dx on the right hand side. Okay, so you are going to do this every single time. And then the next step is you have to isolate dx itself on the right hand side by dividing 12x to the third on both sides. So we have 1 divided by 12x to the third du equals to dx. And then the next step we are going to do a substitution, and that is called the change of variable. I am going to substitute this piece to the differential, the dx. This is called change of variable. So after the change of variable, you have integral 12x to the third divided by the denominator is now u to the fifth, and then the dx becomes 1 divided by 12x to the third du. Now, do you still remember that I picked u equals to 3x to the fourth minus 2? The first reason is for the composition functions thing, and then the second reason is the derivative of that is good enough to get rid of the other piece. The derivative of this u is good enough to cancel the numerator. That's why I let u equals to this piece. Okay, so do you see that the numerators just got cancelled? The 12x to the third. So now all you are doing is you are integrating u to the negative 5 du. So this becomes a simple power rule. Then you have u, negative 5 plus 1 is negative 4, and then you have the reciprocal of that plus c. And then we put the u back to x. So we have 1 over negative 4 times, what is u? U is 3x to the fourth minus 2. And then this is raised to the fourth power plus c. And then this is your final answer. All right, moving on to the second problem. The second problem, we have integral ax to the third minus 10, and then square root 2x to the fourth minus 10x dx. I am going to let u equals to 2x to the fourth minus 10. And then the derivative of u is enough to get rid of the ax to the third minus 10. Okay, and then du is equals to ax to the third. This is the x, right? Minus 10, and then dx. And then you have 1 divided by ax to the third minus 10 du equals to dx. And then you do the change of variable. You are going to put this piece to the differential dx, and this is called change of variable. Okay, and then you have integral ax to the third minus 10, and then the square root of u, which is u to the 1/2, and then the dx is 1 divided by ax to the third minus 10 du, and then you can get rid of the ax to the third minus 10. Do you see that now the differential is du? So every time you finish the cancellation, please double check this. Make sure there are no more x in the integrand, because the differential is du now. So you are not supposed to have dx as an independent variable anymore. So all you can have is number and the variable u. So this is the integral of u to the 1/2, right? So integral of u to the 1/2 plus 1 is 3 over 2. The reciprocal of that is 2 over 3 plus c, and then the u is equals to that. You have that above, so 2 over 3. You have 2x to the 4th minus 10x, and then 3/2 plus c. You can take that as the final answer, but if your instructor don't like rational exponent, then you will have to do this. So 2 over 3, and then the 2 in the denominator is a square root, then you have a 2x to the 4th minus 10x raised to the 3rd power plus c. And then this is your final answer. All right, moving on to the next one. The next one we have integral 3x squared divided by 4 minus x to the 3rd dx. So do you see that the derivative of the denominator is equals to the numerator? So you let u equals to 4 minus x to the 3rd, and then du, that is negative 3x squared dx, and then you have 1 divided by negative 3x squared du equals to dx. So that is going to get rid of the numerator and leave you a negative 1 over there. And then let's do the change of variable. So we are going to do a substitution to the differential, and then you have integral 3x squared divided by u multiply negative 3x squared du, and then you get rid of the 3x squared, but don't forget that there is a negative sign, so, and you can pull the negative 1 out, so you have negative 1 integral of 1 over u du. Is this a simple power rule? No, it is not. Integral of 1 divided by x or integral 1 divided by u, this is an ln absolute value of u, all right? So this is negative ln absolute value of u plus c, and the absolute value is not optional. And then at the end of the day, you have negative ln absolute value of 4 minus x to the 3rd plus c, and this is your final answer. Why do we need to put an absolute value? Because ln negative is undefined. 4 minus x to the 3rd, so let's say x is equals to 5. 4 minus 5 to the 3rd power is negative, so ln of negative is undefined. That's why you need to use the absolute value. When you are doing homework on, if this is a written test, you forgot the absolute value, I can just take credits off on the absolute value. If your exam is online and you forgot the absolute value, you will just get a 0. How do I know? Because I lost points when I was doing this online. I still remember that problem. I spent so much time, so many lines to do the work, figure out the solution, and then all I missed is an absolute value. Guess what? How many points did I earn? 0. Why? Absolute value. All right? So moving on to the next problem. The next problem we have integral 6x plus 6x to the 3rd divided by x squared plus 3x to the 4th. That doesn't look like 4 dx. Okay, so the u equals to the denominator x squared plus 3x to the 4th, because the derivative of that is the numerator. So you have a 2x plus 12x to the 3rd, and then dx. And then you are going to ask me, hey, that is not the numerator. How about this? You factor out a 2. So x plus 6x to the 3rd dx. So now that is the numerator, right? Sometimes you have to do this. And then 1 divided by 2, x plus 6x to the 3rd. And then du equals to dx. And then you do a change of variable. So you are going to replace the differential with that. All right, and then you have integral x plus 6x to the 3rd divided by u, and then multiply 1 divided by 2 times the numerator, and then du. So no more x after the cancellation, right? No more x. So you have 1/2 the integral 1 over u du. So this is 1/2 ln absolute value of u plus c, and then all you have to do is put the u back, right? So that looks like the previous problem, but why do I need to give you a similar problem? Here is why. So you have 1/2 ln, and then the u is x squared plus 3x to the 4th plus c, right? Do we need the absolute value? The answer is no. Why? X squared and x to the 4th they are always positive. You square a number or you take any number to the fourth power, the result is always positive, right? Or 0. You add them together. Even though you pick a 0, 0 plus 3 times 0, that is not negative, right? So that's why using absolute value is not necessary. So this problem, all we have to do is use a parenthesis, because we can guarantee that they are always positive. Okay, and then box your final answer, and that's it. Oh, by the way, if you're wondering, hey, when x is equals to 0, then we have an ln of 0, which is undefined, right? But fine. So for the integration for this function, you have to specify that x cannot be equal to 0. By the way, if you go back to the integrand, the very beginning, when x is equals to 0, there is a 0 in the denominator, so x cannot be equal to 0 at all. Okay, so that is the end of this video. Do you like it? Is this helpful? If so, give me a like, subscribe, and share. I will see you all next time. Signing off.